Shandy mama ahead. He ahead.
Batu bebura komana. Awana liboya. Bulaya na lima. Kuri senchame.
So here now we're going to be talking about functions and operations of functions. Right? Functions and operations with functions, right? So remember a function f a so we need to have an input and an output, right? Okay, it's a rule where whereby each element in set A is exactly one, right? Exactly one or unique is assigned to set B, right? So remember, for every value of 1, they need to be of A, they need to be A tend to be assigned to B, right? So this one is also not a function, because there's something that we call the vertical line test. So if it touches 2 points, that means it's not a function, right? Functions are called, because for each element in set A is exactly 1, or exactly 1 unique to is assigned to set B, right? So now let's talk about domain of a function. So the domain refers to all points where a function is defined. Right? So domain refers to all point where a function is defined. It's like okay, imagine if we have like a machine, right? And then we want to put numbers into the machine, right? So it's like this machine doesn't allow all the numbers, right? So domain refers to all the like numbers. For example, domain refers to all the numbers that the machine can take, right? So the domain refers to all the points where a function is defined, right? So let's have this thing a natural domain. Natural domain. A natural domain refers to all the points. Refers to all the points. To all the points the function is defined, right? Right. So here, in natural domain, there are no extra rules, right? There are no extra rules. So restricted or limiting domain. Or limiting domain. So the domain is restricted to only some part. The domain is restricted only to part. To some part, right? Or parts, right? So, okay, let's start with this one of natural domain. So, okay, f of x is equals to x plus 6 of x plus 1 over x, okay, plus 2 x minus 1, right? We all know that x cannot be equals to negative 2 and x cannot be equals to 1, right? Why? Because if we have negative 2 there, we're going to have a 0, right? And if we have 0, the whole function is going to be undefined. The whole function is going to be undefined if x is equals to negative 2, right? And if x equals to 1, right? So in our domain of function f is going to be equals to x is the element of all real numbers, right? But x cannot be equals to 1 and x cannot be equals to negative 2, right? It's all real numbers from negative infinity up to negative 2 and then union negative 2 up to 1 union 1 up to infinity, right? Yeah, that's what's going to happen today. Our domain is going to be from negative infinity up to negative 2, right? But I remember negative 2 is not included, so we're going to stop at negative 1,9999999, right? But 2, negative 2 is not included, right? and negative from -2, comma up to 1, right? And -2, remember -2 and 1 is not included. So these parentheses, they are very much important, right? Because they are actually not included. That means going to start from -2.00001 to -2.0002. Yeah, right. That means we're gonna start from negative, not -2, man. So negative 1.99999 and negative. That's between these two, right? So that's where x, the function will actually be defined, and then from 1 also, but 1 is not included, and then up to infinity. That means we're going to start by 1.00001, 1.0002, 1.0033, and going until. So here we're going to stop at 0, and here we're going to start at 2.1, and then here we're going to stop at 0. We're going to start at 1.001, and then we're going to go until up to 1.9999999, right? This is also very important. It's a little bit confusing also, right? So we're gonna have the one that is restricted, right? The one that is restricted, it means that like it have rules, right? It have rules that we must operate by, right? Is the function of g of x is equals to 6, x plus 6 over x minus 1, x plus 2, right? And then we're told that the domain x must be greater than or equals to 3. So being given this means that we are actually restricted, right? That's the restriction. That's the restriction, right? So whatever the domain that we must find, it must be actually be greater or equals to 3, right? So that means our answer is going to be the domain of G is equals to x must be element of a real number, but x must be greater than or equals to 3, right? Yeah. So that means x is from up to positive infinity and up to 3, and 3 is included, right? That's why we have this type is a about bracket, right? That's a set notation, and then that's an interval notation. Right? So here we're going to speak about the value of a function. Value of function. Value of a function. So the value of a function is the number f of x the number of x is the value of the function f at point x. Point what? Point x. That means the number g of x is the value of function g at point x. Another, the number h of x is the value of function h at point x, right? So that means h of x, g of x, f of x, right, etc. That's the value of a function. Right? That's the value of functions. So we're gonna have to talk about range. So the range R of f, remember that domain is d of f, right? If it's a function of f, right? So the range R of f of a function is all possible values of the function for all points in the domain. Right? Remember we talked about this machine. So these machines, it takes the numbers, right? But there are some numbers that can't actually go in there, right? And let's say we said that those numbers might be like, that's our domain, right? And then that means that in this machine there are some numbers that can't actually go in there, right? They actually can go to a different machine, right? So the range is like the machine. So right. So when you speak about the range R of f is equals to y must be element of right? Y is equals to f of x for n x is the element of D. That means for a given domain, right? That means that for a given domain. So remember, range is all the possible values of a function for all the points in the domain, right? All the possible values for a function for all domains, because it's not all values of a function that we can get, right? For all points of the domain, right? So that's we get that we cannot get for all the domain that we can put. That means that the ones that are allowed and the one that we cannot get, the one that are not allowed, right? So let's speak it like that, right? So those we have elementary functions. These are like the different types of functions. Right? So we have number one, which is a constant function. We have a constant function. We have a constant function. F of x is equals to c. So just like if f of x is equals to 5. So no matter what we put in here, we must always get an output of what? 5, right? That's a constant function. We have a power function. Which is f of x is equals to x to the power of n, right? For example, that means f of x equals to x to the power of 4, right? And then we have got what we call an exponential function. Exponential function, where for every f of x is equal to a to the power of x, like f of x is equal to 2 to the power of x. And then we have the sine function, where f of x is equals to sine x, right? If for all x is the element of a real number. And then we have got a cosine function, f of x is equals to cos of x when it's an element of a real number, right? So there we're gonna have an example, right, of functions, right? Choose another pen. So yeah, this is an example. So consider the balloon. Consider the balloon with radius r is equals to 10 centimeter. The volume of the balloon is given by Okay, volume is equals to 3 volume volume is equals to 4 over 3 pi r cubed, right? So remember that v is our value of function, and then that r v is our y, and then r is have to be our x, right? This is the output, this is the input, right? And then for every, remember that for every the volume here depends on the amount of the radius that we're actually going to put on this equation, right? And then that means that r is our input, and then that v is our output, right? And then is equals to 4 over 3 pi, and let's put 10, right? Which is equals to, and if we eat everything, we're going to end up getting 41.88,8 centimeter cubic, right? So here are the notes that we can actually make here. Here's what we can actually use. That if the balloon should slowly deflate, right, the volume decreases. And then it decreases proportionally to the radius. Proportional to the radius r, right? So this is what we should actually also note. Right? That radius need to be greater than or equals to 0, and then it need to be less than or equals to 10. That means everything is going to be deflating, right? So remember, it's 0 because we cannot have a negative radius, and that wouldn't make sense, right? So let's have to be equal to something, right? So dv is equals to anything from 10. Our domain have to be from 10. Anything from 0 up to 10, right? So that means the value of volume, at 5 should be given by v at 5 is equals to 4 over 3 pi 5 power of 3, because if we do, we're going to have 5 to 3 comma 6, right? So we also have to know that the set 3 to the power of r, that means we were speaking about the range, right? Is the range. right? So also note that at any given time, a given instant t, there's only one value, right, for the radius of the balloon, right? Therefore, r is the function of time, right? So the formula of the function is not known, and we write r is equals to rt because the volume is naturally also a function of time, right? R t, right? So here let's speak about the even function and the odd function. Let's talk about the even function and also odd function, right? So in even, so even for a function that for the function that we said it must be even, that means the function doesn't necessarily change, right? So that means for every time in the x value, if we put like a negative, it always gives us like a positive functions, right? For example, if f of x is equals to x to the power of x squared, right? This is an even function. Why? Because if we put like a negative there on x, we always get a positive. We always get a positive overall value of a function, right? So let's try it. That means if f of x is equals to, let's put like a negative 2 squared, we know that we're gonna get 4, right? So because we got like a positive function for value of a function, when we when we substituted a negative x value, this means that it's a what? It's an even function. Even function, right? For an odd function, it means that when we put a negative value inside, we always get like what? A negative value of a function, right? That's what happens to an odd function. Negative x, right? So let's put like, for example, if we have like f of x is equals to x to the power 3, and then that means if we place like negative 1, right? F of negative 1, that means we're going to have get a negative 1 power 3, and that means we're going to have negative 1, right? Which means that means we get the negative overall, right? The negative, we'll get the negative value of a function. The negative value of function. This means we get a negative value of function, right? So we also have like something that's called operation of function, right? We can actually add the function, right? We can add function. There's sum of functions. Then there's also bu, we have the differences of function. And then we also have got c, we have the product of function. Then we've got d, we've got like the quotient of function, right? And then we've got e, which is the composite is like the of function, right? So here the sum of the functions we have got we've got f plus g, right? Okay, should probably get like the bigger. Okay, should get like bigger. So remember I said like we've got the sum of functions, the sum of functions. We've got like the sum of functions, which means that for every f plus g as f plus g, we add function f plus function g. Can also denote it as f plus g, and then close bracket x, right? Which is equals to f of x plus g of x, right? And then we have got the difference of functions, right? I also forgot to talk about the domain here in this function. So the domain here, we also have, if we want to find the domain of the functions that are added, we're gonna have to add the domain also. We're gonna have to add the domain, right? That means d of f plus g is equals to d of f, d of g, right? Right, and then we've got the difference of functions. The difference of functions, where f minus g, the function f minus g right, which is equals to f of x minus f minus g of x, right? So these we can, if we want the domain, we can simply subtract the domain of the two, right? So we can just simply subtract the domain right? And then we have got the product of function. The product of function of multiplied by g is equals to f multiplied by g, which is equals to f of x multiplied by g of x, right? So we also have the quotient of a function, right? Which is f over g, which relates to f over g of x, which also relate to f of x over g of x, right? We also have we call the composite function, right? Where f composite g relates to f g of x, right? Now, do you remember here? So if we're gonna find the domain of the two can be actually be equals to 0, right? And then the composite function, so that we're speaking about, so we have that one. That means we have f. Then we have got g of x inside, right? We put something. If we have f of x is equals to x plus 2 and g of x is equals to 4, that means f composite of g of x is equals to, okay, f g of x, which is equals to 4 plus 2, which is going to be equals to 6. Right? So let's do an example for this composite one. Let's do an example. Let's do an example where we have got f of x is equals to 2x plus 1, right? And g of x is equals to square root of x minus 3, right? 2x less than 5, right? So this is what we gonna get. We're asked to determine f composite of g, right? If yeah, so this is how we're gonna solve it. Let's say the f, all right, is equals to f g of x, right, which is actually equals to 2 square root of x minus 3, x square root of x minus 3 plus 1, right? That's the answer that we're gonna get if we have, because now, okay, we placed this one because now we placed this one on there, right? We placed this one there on what? On X, right? So let's find the 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 domain, right? So remember the domain. If you're gonna find the domain independently here, that means here that means x must be greater than 3 because we cannot have a square root of 0. It's gonna give us undefined. Undefined if we're gonna have a square root of 0. So x must be greater than must be greater than or equals to 3, man. No, not square root of 0. Square root of 0 is 0. We cannot have a square root of a negative number, right? We cannot have square root of a negative number, right? So here, this one, x is the element of real number. X is all real numbers, but x must be greater than or equals to 3, right? Right. So the domain we're gonna have x must be greater than or equals to 3 and 2 must be less than or must be less than or equals to x minus 3 less than 5, right? And then here, because we cannot have a want to remove the square root, we're gonna square this side and we're gonna also square that side and we're gonna actually square that side, right? And then gonna have 4 must be less than or equals to x minus 3 so that equals to 25, right? Then and then we're gonna have, let's take this one, let's take it to the other side, right? We're gonna add by 3, gonna add by 3, gonna add by 3, right? So it's gonna give us 7 less than x. Then we're gonna have 20, 28, right? We're gonna have 28, right? So the domain, okay, is equals to Lx is all x value, but x must be greater than or equals to 3, right? And 7 than x 28, right? So here, because we can see that this x must be greater than or greater than or equals to 3, comma 28, right? So we have a reciprocal function, a reciprocal function, right? So a reciprocal function is given by 1 over f x equals to 1 over of fx, right? That's the a reciprocal function, right? And remember, a reciprocal function is not equals to the inverse function, right? Which is fx, right? So a reciprocal function is not is not an inverse function, right? So if you want to, a reciprocal function will be something like this, right? But if that it's on front of f, that means this one is the what? It's an inverse, right? So we also have a piecewise function. We also have a piecewise function. A piecewise function. So f of x to x minus 5, 3x minus 7, x, right? X so in this piecewise function we have got like different we've got like different we've got like different pieces, right? It's the function it have like it's in pieces, right? That's what happens there in the piecewise function.